Um, Hello and welcome. My name is Eunice, and in this video, I'll walk you through my part one of the DevOps technical assessment. We have been able to containerize and productionize the Titanic API. So, this assessment evaluates my ability take a production um, to take a production ready DevOps practice. So let me show you what we started with and what I've been able to accomplish so far. So this is the project, and I created more like a new branch for this project. Um, First of all, this was the initial structure, the run.py, the CSV file, the SQL config. So I created more like a new structure for this application and move all this configuration inside the app directory. So here's what I actually began with: a basic Flask application with a PostgreSQL database to RESTful endpoint for Titanic passenger data, but no containerization, no orchestration, and manual setup instructions. So this is more like the data provided, and I created more like a different directories for each of my implementations, right? So the challenge was to transform this basically what I have under this app directory into a production ready cloud native service following DevOps best practice, right? So this part one is just going to focus on the containerization and the local development. So I'm going to show you my Docker Compose.yaml. This is my Docker Compose.yaml, right? I created a three service architecture using Docker Compose. We have our Flask API application, the Postgres SQL database for data persistence, and PJ admin for database management, all running in isolated containers, right, with proper networking. So I'm going to show you evidence that this is running correctly. So I'm going to do Docker Compose PS just to see. You can see the Titanic API app is running and healthy. And as you can see, all these three services are running an LD, right? The API is on port 5002, Postgres is on 5432, and PG is on 5050. So, I'm going to show you my Docker files. So I sort of like have a structure for my Docker files. I created a directory for my Dockers. I have the dev and the prod. Based on this assessment, it was mentioned that the production Docker file should be less than 200 MB. And so this is my Docker file for dev. For development, I created a multi-stage Docker file that includes build tools for hot reload support. Notice if you can notice, we're not using a root user, non-root user for security reasons, and this is also crucial for production readiness, right? So this is my Docker file for production. The production Docker file also consists of multi-stage builds to create and optimize image under 200 MB. So which I separate build dependencies from runtime, resulting in a minimum secure production image. So I also have more like we have a data, more like a data. So I created a script. I have a directory for scripts here that kind of imports this data. So one key requirement was to automate the Titanic data set import. Right, I created a script that processes the CSV file we have under the app directory and generates SQL insert statements with UUID primary keys. So to verify this, I'm going to run a command from my terminal. So Docker compose um, okay. So I've done Docker compose check SPSQL Titanic. Not sure if I have this already. Dynamic underscore user flag D Titanic see select count from people. Sorry, I have a typo. Postgres. So as you can see, we have 887 counts Titanic passengers successfully imported into our database. So let me show you a sample of this data right now. So I'm going to do docker compose exec. I think I should have, yeah. So this is more like a video demo, right? The survive, the passenger class. This is perfect. Like we have more like a real Titanic data, including passenger name, survivor status, and class information. So I'm going to I'm going to perform like an API demonstration right now, just to like test the call. That's our local 5002. So I'm going to do call HTTP localhost 5002. Can see the API is running and accessible, right? Now let's test the main endpoint that returns all passengers, right? So let me do echo testing people endpoint. I have this already. Uh, yeah, can see the API is returning all 887 passengers. Notice the JSON structure, right? And includes UUIDs, which are better than sequential IDs for distributed system. So another thing we can test is to create a passenger. Think of Let's create a passenger just for this demo. Um, just video demo. I think I've done this before. Just for the purpose of this video, I'm going to do this again. Then we've been able to create this passenger age. You can see this data right now, right? The age. So so um this shows that we've been able to like create a new passenger, right, with a generated UUID now. Now let's more like retrieve this specific passenger, and then we get a specific passenger, replacing it with the UUID with actual we replace it with UUID. Um so let's just do that. UUID. I've run this command before because yes, so let's see if we can retrieve it. So yeah, we can retrieve more like individual passengers by UID. So another thing I want us to try is just to like update this particular passenger. So let's more like echo update. I think I have this also. So this age to age 30, right? updating demo passenger. Okay, let's see this. So the update worked. You can notice that the name and the age have changed finally. So we can we can clean this up. Um, let's just delete. I think I should have this too. So we're able to like delete. The passenger has been successfully deleted. So we've been able to demonstrate that the full CRUD operations on this API. So now another thing I want to check is the health and security features. So the Docker Compose PS should show this. So I think it's Docker. Okay, I have that command. You can see that both container shows LD, and I implemented more like an health checks. The API checks HTTP connectivities and Postgres uses is ready. Um, this is so these are essential for production monitoring, right? So now I want to demonstrate the security features. So you can see that it's running as non-root user Titanic and environment Flask env. There we are running as a non-root Titanic user, and all configuration uses environment variables. No hard-coded secret. This sort of like follow best practice, right? So I just have to like these are the more like environment configurations. So so for production readiness, I created more like a script for the purpose of this video. And what the script is doing is to check the size just to be sure that we're able to like meet all the requirements for the production Docker file. So I already built the production image before this video. So what I'll be doing is just to run the script, and it will help show the current implementation. So I'll just do video and production demo. So you can see that the multi-stage and image is 185 MB, which target was less than 200 MB, right? It's not running as root, it's running as Titanic. Let's check its container started successfully. And yeah, so that's it for this part one requirement. Shows that it has been successfully implemented and verified, containerized, production ready, Titanic API with complete DevOps practice. So yeah, thank you.